Hello viewers. Today we will explore one of the most recent discoveries of 2025. A newborn gas giant planet, WISPIT 2b, the first confirmed planet found inside a multi-ring disk around a star. We're going to explore what this system looks like, how astronomers actually spotted a planet hiding in a dust ring, and why this discovery is a massive win for our theories of planet formation. Let's jump in. Astronomers were running a survey of young stars, taking quick, snapshot images to look for wide-orbit gas giants. When they pointed their telescopes at a sun-like star, called WISPIT 2, they found something unexpected. Instead of just a faint companion, they saw a stunning multi-ring disk, bright bands of dust separated by dark gaps, a structure that looked like a cosmic vinyl record. The disk stretches out to about 380 A, far beyond the size of our solar system. Those rings and gaps were a huge clue that something interesting was happening. For years, simulations have suggested that forming planets are the sculptors of these structures. But until now, the planets themselves were frustratingly elusive. Once the team saw the rings, they immediately requested follow-up observations. Using the Very Large Telescope in Chile, they took deeper near-infrared images of the system. In one of the main gaps, they spotted a small but clear point of light, WISPIT 2b. Over several years, they watched that dot move with the star, proving it wasn't a background object. Then came the clincher. Astronomers used special instruments to observe the planet in H-alpha light, a specific red wavelength emitted by hot hydrogen gas crashing onto a young object. That glow is direct evidence that the planet is still accreting gas, growing its atmosphere. So we're not just seeing a planet. We're seeing a planet in the act of being born, embedded in the very disk that feeds it. WISPIT 2b is what astronomers call a protoplanet, a planet still under construction. It is several times more massive than Jupiter, only about 5 million years old, orbiting roughly 57 A. From its star, deeper into the system than Neptune is in our solar system. Because it's so young, it's still hot and glowing in the infrared, making it easier to image than older, colder planets. Its mass and position also line up beautifully with simulations of a planet massive enough to open a wide gap and herd dust into rings. It's basically a real-life version of what we think Jupiter and Saturn might have looked like long ago, only caught with modern telescopes in another solar system. Protoplanetary disks around young stars often show spectacular patterns, rings, gaps, and spirals. For years, the leading theory has been that hidden planets are responsible. They clear material along their orbits, creating gaps. Their gravity piles up dust at the edges, making bright rings. Massive planets can launch spiral arms in the gas. But until WISPIT 2, we didn't have a system where we could point to a multi-ring disk and directly see a planet sitting neatly inside one of its gaps. With WISPIT 2b, we now have the first confirmed case. It's powerful evidence that those beautiful structures really are the fingerprints of forming planets. WISPIT 2b is a laboratory for planet formation. Its properties help us test different theories. One debate is how giant planets on wide orbits form. Disk instability. The disk rapidly collapses under its own gravity, forming a giant planet quickly. Core accretion. A solid core slowly grows and then pulls in gas from the disk. WISPIT 2b is massive, but it sits in a gap whose shape and width match what we'd expect from a world that grew slowly by core accretion and then carved its neighborhood as it bulked up. That suggests that even far from the star, core accretion can work, which has big implications for how common wide-orbit giants might be. By measuring the gap, ring brightness, and dust distribution, astronomers can also estimate the disk's viscosity, essentially how easily material flows. That's a key, but poorly understood, parameter in all planet formation models. WISPIT 2b gives us a rare chance to pin it down. Our solar system started with a disk too. We think Jupiter and Saturn may have opened gaps and influenced how material moved inward, shaping which planets formed where and how much water reached Earth. WISPIT 2 lets us watch a similar story, but from the outside. It's like seeing a baby picture of a planetary system that may evolve into something loosely like our own. By studying systems like this, we understand not just how planets form in general, but how Earth-like worlds might emerge in the shadow of giant neighbors. So, to sum up, WISPIT 2b is the first confirmed exoplanet discovered inside a multi-ring disk around a star. It's a still-forming gas giant, glowing in infrared, carving a gap in a huge dusty disk around a young sun-like star. This discovery turns a long-standing theory into something we can actually see: rings and gaps sculpted by a real planet in real time. It's a major benchmark for planet formation science, and likely the first of many such planets we'll find as our telescopes and techniques get better. If you enjoyed this deep dive into WISPIT 2b and the birth of a planetary system, please like the video, subscribe to Exomysteries, and hit the bell so you don't miss our next journey into the cosmos. Thanks for watching, and keep looking up.